In this video, we're going to continue our lesson on trigonometry. So far, we have learned about how to label the sides of our triangle based off of where our angle measure is located that we're looking at. We use the symbol theta to represent that angle measure. We talked about trigonometric ratios, sine, cosine, and tangent. And so far, we've talked about finding missing side lengths. So in this lesson, we're going to look at finding missing angle measures. I do want to point out before we continue that this example is similar to the one that we looked at in the last lesson. This is the last lesson where we have theta was 30 degrees, we know the hypotenuse was 8, and when we solve for the missing side length, we were found it was 4. So I want to show that this answer will be theta equals 30 degrees. I want to write that down now, just so when we actually do solve for the solution, you'll see that it will be 30 degrees. Okay. To find the missing angle measure of our right triangle, given 2 of the side lengths, we are going to first label those side lengths based on where theta, or the angle measure we're looking for, is located. So you can again see we've labeled this the opposite, the adjacent, the one next to that theta, and the hypotenuse, the one across from that 90-degree angle. So just like finding a missing side length, we have to decide which trig ratio to use. I can see here that we have our opposite and our hypotenuse, not the adjacent. So we're going to use our sine ratio. All right, so I'm going to substitute sine of theta equals, this was our opposite over hypotenuse, so sine theta equals 4 over 8. If you want to simplify that to 1/2, that is perfectly fine. You can leave it like 4 over 8 for now, but just want to let you know you can write that as 1/2. Now at this point, we are going to have to solve for theta, the missing angle measure. And anytime you're trying to isolate a variable, in this case our theta, you do the inverse operation. Just as if you were to just show division, it would be multiplication. Just like if you saw addition, you would subtract. In this case, we're going to use what's called the inverse trigonometric ratio. So the inverse of sine is exactly that, inverse sine. So what I can do is I can take what's called the inverse sine of that whole side of our equal sign to eliminate the sine function. But what you do on one side, you have to do on the other. Okay? So let me just get rid of that for a second. I'm going to write it over here. So sine of theta equals 4 over 8. I'm going to take the inverse sine of both sides, because what you do on one side of an equal sign, you have to do on the other. So when you take the inverse of sine, they are eliminated, and you're left with theta. So on the other side of the equal sign, you have inverse sine of 4 over 8. Just writing the sign, it looks like a little exponent with -1. At this point, it's where you use the calculator. So I'm going to show you where the inverse sine is first on the TI-34. So on your TI-34, again, just from our previous video, usually there's the symbols here, sine, cosine, tangent, and above them you would see inverse sine, inverse cosine, and inverse tangent. But on this specific type of calculator, I'm going to have to use my trig function here. I'm going to hit second trig, and you can see it says sine -1, right, or inverse sine. I'm going to scroll over and hit that and enter, and now I can just type in 4 divided by 8, and it comes out to 30, or 30 degrees, which is what we said the answer should be from the beginning. So it's pretty quick and easy with the calculator. You can do it all in order. Now, how can you do it on, let's say, an iPhone calculator? On your iPhone calculators, you should see sine, cosine, tangent, but do not click the ones below it, right here. We're not going to use those. On your iPhone calculators, you should see a little second symbol here. When you click that second symbol, it opens up other calculations behind those symbols. So if I hit the second key here, you can see that the inverse sine, inverse, cosine, and inverse tangent came up here. So there they are, sine, cosine, tangent, and there are the inverses. So what I'm going to do is I want to do 4 divided by 8, hit equals, and then I'm going to hit second, and then the inverse sign, and it comes up with 30 degrees. One more thing before we go to a few more examples is I want to make sure that you are looking at this in degrees and not another unit called radians. If you don't see anything written here, that's good, right? If this did say RAD, or radians, a different type of unit we use to measure our degree measures, we're going to just click right here, DEG, to get rid of that. So now it actually is in 30 degrees instead of radians. Let's take a look at some examples. What is the measure of x to the nearest degree? My first step, measure of angle x. My first step is to first put theta right here at angle x. All right, that's the angle measure we're trying to find. Across from that is our opposite, making this the hypotenuse and this the adjacent. So I can see here that I have my opposite and hypotenuse. I don't have the adjacent. So which trig ratio uses the opposite and hypotenuse? That would be sine. So I'm going to write this as the sine of theta equals the opposite 6 over 10. Now I'm going to skip a step here a little bit, but you can go back and look at the previous example. I'm going to write this as theta is equal the inverse sine of 6 over 10. All right, you have to take the inverse of the left side, which would eliminate that sine function to just be theta, and you would take the inverse of the other side. So in your calculator, second trig, in my case, sine, inverse, 6 divided by 10 equals. The angle measure, if I were to round to the nearest whole number, would be 37 degrees. If we're rounding to the nearest tenth, it would be about 36.9 degrees. I'm going to round to the nearest whole number in this example, and I'm going to say theta equals 37 degrees right here. Let's use the iPhone calculator just so you can see another example. I'm going to first write 6 divided by 10. Right now I see sine, cosine, and tangent, so I want to hit second, then that inverse sine symbol, and it still comes out to, when I round up, 37 degrees. Let's do one more example. My first step is to always label, and in this case, theta is not down here. I'm still trying to find the measure of angle x. Theta is going to be up here. So this is our opposite, this would be our adjacent, this would be our hypotenuse. I don't know the opposite, so I'm going to get rid of that one. Which trig ratio would you use if you have the adjacent and the hypotenuse? Adjacent, hypotenuse. We're going to use cosine. Cosine theta equals the adjacent over the hypotenuse. If you wanted to simplify these fractions, you can. You don't need to solve this problem. So now, since I want to get theta by itself, I'm going to do the inverse cosine on the left. That would be eliminated. And you do the inverse cosine on the right. So this is going to become theta is equal to, sorry, different color. The inverse cosine of 15 over 20. We're going to take our calculator. Second trig. Scroll over until you see inverse cosine and hit enter. 15 divided by 20 equals, and rounding this to the nearest whole number, theta equals 41.4 degrees. or sorry, 41 degrees. Let's do this on the iPhone calculator. I want to take the inverse cosine of 15 divided by 20, so 15 divided by 20. And then we're going to hit our, remember this is sine, cosine, tangent, so we're going to hit the second key and do the inverse cosine, and we still get that same solution, 41.4, or in this case 41 degrees.